differential equations here, and the learning goal is to separate dx and dy and integrate with respect to x and to y. Okay, now the success criteria here gives us a checklist of what we need to accomplish. So we need to separate dy and dx to separate sides of the equal sign, putting dx with all the x's and putting dy with all the y's, so we can actually function that. Now, how does that look like? Well, let's get into the example. Okay, so it says integrate this. Okay, so what I'm going to do is I'm going to do exactly what the success criteria is, and I'm going to move the dx, I'm going to separate dx and dy. So the first thing I'm going to do is multiply both sides by dx, so that gets rid of it there. That means we've got dx over here. So I'm left with just x dy is equal to 3 minus y dx. Now the issue here is that the second part of the criteria is that I need to put all the dx's with the x's, and I've got the opposite happening. So I'm going to divide both sides by x, get rid of that, put x there. So actually that is exactly what I'm going to do. And the other thing I'm going to do is at the same time I'm going to move this one over there by dividing as well. So I'm left with 1, or dy over 3 minus y is equal to 1 over x dx. Alright. Now, I just want to explain this step as well. So at the same time that I divided by x, I divided by this as well. So I could change it to the other side. If you're struggling with this, you need to work on your algebra. Okay, so I'm going to keep going with this. So now I'm ready to integrate. So I'm going to integrate both sides. So I'm going to go like this, and I'm going to go 1 minus 3 minus y dy is equal to 1 over x dx. Now this right hand side is very simple. It looks like it's just the log of x. So it's going to be log of x plus c. And this side, it looks like it's going to be log as well, because the derivative of this is just going to be -1. So it looks like I can compensate by just putting a negative here and putting another negative there. So that will equal negative log of y. And then I'm not going to do a plus c because we have a plus c here. That's enough for both sides. Okay. So essentially what we're doing is that we're separating dx and dy, and then we're putting dx's with x's and dy's with y's. Alright, for the differential equation, find the solution curve passing through 0, 1. So what I'm going to do is I'm going to do the same thing as before. I'm going to separate it. Now, there's a really big hint of why I want to separate it. It's because normally when we integrate something, we have all x's or all y's, essentially all x's. Now we've got x and y, so I'm going to separate them both. Okay, so I'm going to go dy equals xy dx, and then obviously I'm going to divide both sides by y, so I get 1 over y dy is equal to x dx. Now I'm going to integrate both these sides. So the integral of the left hand side looks like just log of y, and this one looks like x squared on 2 plus c. But we actually have a little bit more information here that we can get rid of the c. It says this curve passes through the point 0, 1. So when x equals 0, y equals 1. And this is actually really convenient because log of 1 is just 0. And then this one's going to be 0 squared over 2 plus c. So therefore, c equals 0. So therefore, we know that the solution curve passing through the 0, 1 is simply log of y is equal to x squared over 2. Okay, and if I wanted to make it equal to 0, which I can just move this over here and make it equal to 0. All right, let's do one more example. It goes integrate and make y the subject. So I've just got another version of dy dx. So what I'm going to do is I'm going to go dy dx, so rewrite y dash as that. And then I'm just going to go off and start working with it. So I'm going to move the dx to the other side. So I've got 8x e2y dx. Now I'm going to move this to the y's to the other side, move this to here. And that's simply going to be e2y, dy is equal to 8x dx. All right. And now it's my turn to integrate both sides. So I'm going to integrate both sides. And the integral of an exponential is going to be itself. And I'm going to multiply it by 2 because that's the derivative of here. And the right hand side is simply going to be 8x squared on 2 plus c. So obviously that's going to go down to a 4. All right, and we need to make y the subject. So I'm going to do this, e2y, and I'm going to multiply, divide everything by 2 so I can get rid of this guy. And I end up getting 2x squared plus c1. So all we have this constant and we don't know what it is. I've divided by 2, but it's just going to be another constant. So I'm just calling it c1 just to note that it's different. Okay, now the question is to make y the subject. So I'm going to log both sides. So I'm going to get 2y equals log of 2x squared plus c1. And then my final answer will be therefore y equals log of 2x squared plus c1 over 2. And I've made it y the subject. Hopefully that makes sense. Peace out.